Circuit Analysis Boot Camp by Luz EE Lab. www.luz-ee.com. info@luz-ee.com. Circuit analysis is probably the most important electrical engineering fundamental course. Many universities require that students take this course to determine who will make the cut and continue in the degree program. For anyone interested in joining electrical engineering field, circuit analysis is also the best course to test the waters. Can I learn circuit analysis in one day? Probably not. You need time to practice. Can I learn circuit analysis fast and efficiently? Certainly. And this is the goal of this bootcamp. How to learn it fast and efficiently. 3 steps. Understand the concepts. Avoid common issues. Practice. Concepts including Kirchhoff's current law, KCL, Kirchhoff's voltage law, KVL, nodal analysis, mesh analysis, superposition, Thevenin equivalent circuit, Norton equivalent circuit. Here is the example circuit. How much is VA? The first approach, using KCL and nodal analysis. From KCL, I1 plus I2 plus I3 equals 0. Expand this equation to get the node voltage VA. Nodal analysis by replacing I1 by VA minus V1 divided by R1 and replacing I2 by VA minus V2 divided by R2 and replacing I3 by VA divided by R3. Bring the voltage source and resistance values into the equation, and the calculate VA is 10.91 volts. Second approach, using KVL and mesh analysis. From mesh analysis, R1 multiply IA plus R3 multiply IA minus IB minus V1 equals 0. R3 multiply IB minus IA plus R2 multiply IB plus V2 equals 0. Each equation of the mesh analysis is a KVL loop. Thus, IA and IB can be calculated, and then VA can be calculated based on IA and IB. Resulted VA is 10.91 volts as well. The third approach, using superposition. Turn on sources one at a time, and then add the resulted VA together. VA1 can be calculated by the voltage divider made with R1 and R2 R3 in parallels. The resulted VA1 is 60/11. Similarly, VA2 is 60/11. Add VA1 and VA2 to get the total VA, which is 10.91 volts as well. the same results as the previous two methods. This circuit can be simplified to a Thevenin equivalent circuit made of VTH and RTH. VTH is the equivalent terminal voltage when there is no load. VTH is equal to the VA, calculated before, so VTH equals 10.91 volts. RTH can be calculated by shorting all sources. So, RTH is equal to the paralleling resistance of R1, R2, and R3, which is 5.45 ohms. This circuit can also be simplified to a Norton equivalent circuit. IN equals VTH divided by RTH. RN equals RTH. The following are the top common issues I found from past students. 1. Making random mistakes here and there. Solution to this would be: make sure the concepts are clearly understood. Practice more. You can just do your assignment 2 times. 2. Looking at the problem and not sure how to get started. Solution to this would be: sometimes a problem has several approaches, just pick the one right from your instinct. After practicing more, you will have a better judgment to pick the easiest method. 3. Familiar with the main concept of the problem, but still not able to get the right result. Solution to this would be: the most common calculation issue is from either voltage or current divider. They are so widely used in this course, and so widely get confused as well. Voltage divider versus current divider. Voltage across R2 is VA equals V1 multiplied by R2 divided by R1 plus R2. Current going through R2 is IA equals I1 multiplied by R1 divided by R1 plus R2. After understanding the concepts and avoiding common issues, all you need to do is to practice. Practice is essential for this course, do not skip this step. Any questions? Contact me at LuzEELab, www.luz-ee.com, info@luz-ee.com. Mention promotion code Good Day to get a free half-hour tutoring of circuit analysis. LuzEE, premier tutoring services made affordable. Click subscribe to stay connected.